This lesson's about cross multiplication. This is a really helpful algebra technique when solving an equation where you have a fraction equal to another fraction. It only works when you have an equal sign. Many people want to do this when there's no equal sign. They're simplifying a left side or right side. Well, we have rules for multiplying or adding fractions that are different than this. So you need to go back and consult that if that's your question. But where there's a fraction equaling a fraction, this is a great technique. Let me show you a couple examples. First one here will be a more basic one. 3 over x equals 4 over 7. What is x? You might try to guess. Is it 1? Well, no, that'd be 3 equals 4/7. No. Is it 2? No. This is going to be tough to guess, I can see. It's going to have to be bigger than 3 because 4/7 is less than 1. But you don't have to think that hard. You can just use cross multiplication. And really, it's not a magic technique. Maybe I'll show you kind of what's going on, and then I'll show you the technique the way I would typically do it. Really what's happening, again, it's not magic, is you want to get x by itself. So you could just think, hey, let's get rid of the 3, but x is in the denominator. So first thing I'm going to do is get x out of the denominator. And again, this is like a long way of doing cross multiplication. This really is not cross multiplication, in fact. And you get here. That's the same thing as, I guess you could just say 3 is 4x over 7, right? Because that x is really in the numerator. Then you can multiply both sides by 7, and then you can divide both sides by 4, and this is taking a while. We finally get 21 over 4 is x, and we'll talk about that decimal in a moment, but that's your answer. I guess we could box it. But this cross multiplication thing is pretty awesome, so let's show you what you can do with that. Cross multiplication, and I wrote or, but really this is by far the preferred, says, you know what, you can do this real quick by just multiplying. Let's get a different color out for this. Multiplying the items that are kind of diagonal from each other. So it kind of feels gimmicky, but really you'll see that we're doing the same thing we did before. So you do the 4 times the x, which is 4x, and the 3 times the 7, which is 21. And look, you are the same place you were right here, but you did it in one quick step. And again, really, you multiply both sides by x, that's where the 4x came from, and both sides by 7, that's where the 21 came from. So it just does the same thing, but much more quick and efficient. So now we wrap this up by dividing both sides by 4, and we get x is 21 over 4. You can't reduce that fraction, you should try. So you could leave it that way. I'm totally fine with that. If you wanted to go decimal, you might try to do it in your head or put it in your calculator. It turns out to be a pretty nice one, 5.25. If I can get the 5 to show up. There we go. 5.25. Sorry, my handwriting is not that great, and I'm running out of space over here. 5.25. That's fine because that decimal terminates. If the decimal just went on and on, I would not recommend you writing as a decimal because then you're rounding. And unless they specifically tell you what to round to, you don't want to round. So we're going to leave that as either one, though. But say if you had like, 2 over 7, which I think is 0.28571428, and it goes on and on and on. Well, you don't want to just write 0.28 or 0.3 unless someone tells you what to round to. If they don't tell you, they're wanting the exact answer. So just leave it as a reduced fraction. 2/7 would be more appropriate. But that's just a side note. Let's do one more of these. Okay, finally, this one's got a little bit more going on. X plus 3 over x minus 2 equals -7/4. I'm kind of trying to show you some extra things here too. Look at that negative, just kind of hanging out there. Does it go with the 7 or the 4? And really, I meant to make it perfectly centered. Let's see if I can do better doing that. Yeah, look at that. Who takes the negative? They might be fighting over it. You might think, let's just make both of them happy and give it to both. Let's just see what that would do if you gave it to both. Oh, they're so happy now. They both have a negative. Oh, wait, but what's a negative divided by negative? It's a positive. Ooh, the negatives are gone. So that means -7/4 equals +7/4? No, that's nonsense, right? A negative doesn't equal a positive unless it's 0. you can't let both of them have it. You have to pick one, okay? You have to play favorites. I usually say, let's give it to the top guy just to be consistent. If you want to go with the bottom one, that's fine. I'm just going to give it to the top one. Okay, now let's cross multiply. Negative 7, I'm going to make a mistake, see if you can catch it here, times x minus 2, let's put a little dot there, equals 4 times x plus 3. Well, speaking of playing favorites, we've done that here as well. Poor negative 2 was real excited about being multiplied by 7. He's down here, right? Let's see if we do that. I wouldn't recommend doing this thing over and over. It's just going to get real crowded. But if you did, you'd see that. Negative 2 was going to be multiplied by negative 7. Negative 2 and x by negative 7. But we only multiply the x. In a similar way, the x and the 3 were going to be multiplied by 4. But we only multiplied the x. What are we missing? Parentheses. You have to know to put your own parentheses on a problem like this, because you're multiplying negative 7 times all of x minus 2, the quantity of x minus 2, and 4 times all of x plus 3, the quantity of x plus 3. So don't forget those parentheses. That's pretty important. From here, this is a pretty easy problem. Distribute. That looks right, I think. Then let's move all the x's to one side. Negative 11x plus 14 equals 12. Let's move all the non-x's to one side. I'm running out of space here. Negative 11x is negative, equals negative 2. Double check that. Looks good. I'm going to do this because I don't have much room on here. Let's just copy that down again. Now you're going to divide both sides by negative 11. And you get x is 2 over 11. That's equal to, I think, 0.18181818. I think that's right. I don't really want to write those out. Yeah, you could do, but just leave a reduced fraction. You could do this move, 0.18 repeating. That's fine, but 2/11 is better. Unless, again, there's kind of a word problem and you really need context. Most people understand 0.18 repeating better than 2/11, but in just pure algebra, 2/11 is fine. Hope this helped.
Made with Doodlecast Pro.